Hello, and welcome to the video on sections 29.1 and 29.2, square roots and higher order roots. Let's get started with some important terms. The root of a number x is a number when multiplied by itself a given number of times equals x. A few examples of these. The second root, also known as the square root, of 16 is 4, because 4 times 4 equals 16. The third root, or cubed root of a number, of 27, is 3, because 3 times 3 times 3 equals 27. The fourth root of 16 is 2, because 2 times 2 times 2 times 2 equals 16. So as we notice in those three examples, 4 squared is 16, so the square root of 16 is 4. 3 cubed is 27, so the cubed root of 27 is 3. And 2 to the fourth power is 16, so the fourth root of 16 is 2. A radical will denote your square root, and we've drawn that here for you. As you notice, there is no number in the little valley at the very beginning of the root. You can write a 2 there, but it's not necessary. The radical with the 3 is denoted as the cubed root, the one with the 4 is denoted as the fourth root, 5 is the fifth root, and so on. Let's look at a few examples. So let's look at the square root of 10. Square root of 100. We know 100 is 10 squared. The square root of 10 squared, or 100, will be 10. So when we have a fraction, we're going to rewrite that with the radical in the numerator and the denominator. And we know that the square root of 9 is 3, because 3 squared is 9. And the square root of 25 is 5, because 5 squared is 25. So we look at example number 3 here. We see there's a negative out in front of the radical. That means nothing until the end. So we're just going to rewrite that negative. And with the square root of 49, we know 7 times 7 is 49. So our answer is 7. And we leave the negative out front, so the answer would be negative 7. Square root of 0 could be tricky, but it's not. We know 0 squared is 0. Now we get to a tricky one. Number 5. We're showing the square root of negative 144. There is no number that you can multiply by itself and get a negative number, because 12 times 12 is 144, and negative 12 times negative 12 is 144. It will never equal a negative 144. So therefore we have no real solution. And let's see if I can write that a little clearer for you. Once again, we look at number 6. There's a negative underneath the radical, so we're going to have no real solution. We will figure out what we can do with those later when we deal with imaginary numbers. Move on to a few more examples. Number 7, we have variables, which isn't difficult. So if we look, we can break that up. The square root of 25 and the square root of x squared. We know that the square root of 25 is 5. Now, anything squared, its square root is just going to be itself. So if we take the square root of x squared, it's just going to be x. Let's look at number 8. Now we have a negative underneath the radical, but that negative is in parentheses and being squared. So if I square negative 6, I get 36. And if I square x, I get x squared. So now we're safe. There's no negative underneath the radical. And so I'm going to have the square root of 36 x squared. The square root of 36 is 6. And the square root of x squared, as we done earlier, is x. Let's deal with cubed roots. Remember, cubed roots are what cubed. So if I look at 8, what is 8? What makes 8 that is cubed? Well, we know that 2 times 2 times 2 equals 8. Therefore, the cubed root of 8 equals 2. So now we have a negative underneath the radical again, but this time it's a cubed root. So if I were to take negative 2 cubed, I'm going to get a positive 4 times the negative 2, which is negative 8. So we know the cubed root of negative 8 is going to be negative 2. Number 11, we're looking at another fraction underneath the radical. We're looking at the cubed root of 8 over 27. Just like a square root, we take the cube root to the denominator and the numerator. So the cubed root of 8, as we figured out earlier, was 2. And the cubed root of 27 is 3, because 3 cubed equals 27. Number 12, we're dealing with another negative underneath the radical, but once again we see that it is a cubed root, so it's okay. So we want to know what cubed is negative 64. Well, we know 2 cubed is 8, so negative 2 cubed is negative 8. We knew that 3 cubed was 27, so negative 3 cubed would be negative 27. So let's look at negative 4 cubed, which is going to be negative 4 times negative 4 times negative 4. So we're going to get a positive 16 times a negative 4, which will give us negative 64. So we know the cubed root of negative 64 is negative 4. A few more examples here. Now we're dealing with the fourth root. And as we talked about earlier, the fourth root, we want to know what to the fourth power is going to be underneath the radical. There's a trick as well that we can use on fourth roots. To get a fourth root, we can take a square root twice. So I can take the square root of the square root of 16. Well, the square root of 16 is 4. So now we're left with the square root of 4, which is just going to be 2. Same thing here with the fourth root of 81. Let's take the square root twice. Well, the square root of 81 is 9, and the square root of 9 is 3. So here with number 15, we have just a radical, and we're using the sixth root, which we have not yet seen. There's a little trick to these. What we want to do is we want to know, we turn what's inside the radical into a square. Well, we know that x to the 6th power, excuse me, did that incorrectly. We want to know what to the 6th power. So we're looking at x squared to the 6th power. Now that is x to the 12th, as we multiply our exponents. So the 6th power, or the 6th root of x to the 12th, is x squared. Another way we can do that is set it up as a fractional exponent, which we will learn more about later. Same thing here. On number 16, the 5th root of y to the 25th. We know 25 divided by 5 is 5. A few more examples and then we'll be done. We're going to do the same thing on 17. We're going to have a to the 9/3 power and b to the 30 over 3 power. And when we simplify those, we're going to get a to the 3rd and b to the 10th. We take our root and put it as the denominator and the power that's underneath the radical as the numerator. Same thing here. Break this up into the cube root of 27 and the cube root of x to the 9th. We figured out the cube root of 27 earlier is 3. And x to the 9th, cube root of x to the 9th is going to be x to the 3rd. Number 19, we have the square root of 16 and the square root of x to the 4th. We know the square root of 16 is 4. And the square root of x to the 4th is x squared. And for number 20, you're probably getting the idea of it. Square root of 64, square root of y to the 10th, square root of 64 is 8, square root of y to the 10th is y to the 5th. With our exponents, we're going to make sure that we divide the exponents by the root, and that's going to give us the new exponent after we take the root. Thank you for listening to this video, and good luck on your homework.